Hello, everyone. In this lesson, I want us to look at lifting devices or the hoisting devices. You must be able to define a machine. A machine is defined as a device in which forces are applied in order to do work. So we can have a simple lifting machine where you use a minimum force to raise a larger load. We can have the crane and the other types of lifting devices. Now, on a machine, there are three quantities that are used to evaluate whether the performance of machine is good or bad. And these three factors are called, the first one is a mechanical advantage. The symbol that is used to calculate mechanical advantage is MA, and it is defined as the ratio between the load lifted and the effort applied. Symbol of mechanical advantage is MA, and it will be equal to L for the load divided by E for the effort. The load must be in Newton because it is the weight that must be raised. And the effort is the minimum force that you put in is also measured in Newton. So the mechanical advantage will have no SI unit because the ratio between the Newton and the Newton. If M or if the weight is given in kilograms, you're given the mass of the object, always convert it into Newton. If it's given in grams, tons, megagrams, always convert to newtons to a weight. Second quantity that is used to evaluate the performance of the machine is called the velocity ratio, or it's called the displacement ratio. It's VR or DR. It is the ratio between the effort distance and the load distance. So in order to raise a load, the distance between a turning point and the effort must be larger than the distance between the load and the turning point so that you can achieve the larger result. It is also a ratio between the distances. It will also have no units. This distance of an effort divided by the distance of a load must be of the same units. You can keep both in millimeter, both in centimeter, both in meter. For as long as they are both of the same units, you get the same answer. Then we'll have no SI unit because it's a ratio. The last quantity that is used to evaluate performance of any machine is called the efficiency. Efficiency is also a ratio between the output work over the input work. Now we have two quantities, or we have force called the load and a distance called the load distance. So force and distance gives you work done. We also have a force called effort and a distance called an effort distance. So when you multiply the two, they give you work done because it's force times distance. Between the load and the effort, effort is the minimum force you put in. So it will be the input work. And the load is what you achieve after you've applied an effort. So the load will be the output. Let's just look at this because the formula might not make sense. Since it's told the formula, the definition is talking about the output work and the input, but the formula has mechanical advantage. Let me just show you how to get to this formula. Efficiency is output over the input. So the output is the load. So it will be L for load, force times distance, work done. So it will be times, let me use the S for the distance and put L for the load. So distance is S, since it's for the load distance, divided by the effort multiplied by distance of the effort, SE. Then this is multiplied by 100%. Load over effort is mechanical advantage. MA is load over effort. Velocity ratio is given by effort distance, which is SE, divided by load distance. But what we see here is load on the numerator and the effort on the denominator. So it's not VR, but what we see is 1 over VR, is the inverse. If it was VR, the effort would be on the numerator and the load on the denominator, because formula of VR is effort over load distance. Now, where there is this SL over SC, we're going to put 1 over VR because it's the inverse of velocity ratio. Multiply by 100%. Then MA times 1 will be MA divided by, this is over 1. This is divided by VR, multiplied by 100%. So this is where this formula of efficiency is coming from. It's mechanical advantage divided by a velocity ratio multiplied by 100. So to calculate or to evaluate a performance of any machine, you need these 3 quantities. You calculate mechanical advantage of that particular machine. You calculate its velocity ratio and the efficiency of a machine. Next, we have the specific machine or the other machine that has the specific formulas. These type of machine or types of hoisting device that are considered in this chapter is called the differential wheel and axle. And the second one is called the differential pulley block. And the last one is also called a differential winch. So if a question is asking, what are the types of hoisting devices? These are the 3 types of hoisting or lifting devices. There are 3. There are only 3 types of hoisting devices. So the second one, which is the differential pulley block, is also called Western pulley block. Western pulley block. You must be able to sketch these types of machine. You must be able to do calculation under this type of machine, as long as a simple lifting machine can be a hydraulic crane, it can be a lever. You must also do the calculations based on a lever. The diagram or the sketching. This is the sketch of a differential wheel and axle. It is that type of machine that has a shaft, and kit on this shaft there are 3 drums. The bigger, the smaller, and the medium and the largest. The larger pulley is called the wheel, and its diameter is labeled as capital letter D. The one in the middle is called the larger axle. So the 2 smaller drums are called the axle. This is the wheel and axle. So the 2 diameters are called the axle. For the bigger axle or the large axle is labeled as D1. And the smaller one is labeled as the D2. This is the shaft, and the shaft is fixed at both ends. Mechanical advantage of this machine is load over an effort. Load is this weight that must be raised or hoisted. It must be newtons. Effort is the minimum force that you apply on the larger wheel or on a wheel. Velocity ratio of this wheel and axle is 2D, which is twice this, divided by D1, the larger axle, minus the diameter of the small axle. Efficiency is mechanical advantage over VR, which is this answer of the first one divided by the second one multiplied by 100. You must be able to sketch it and do calculations. The second machine is called the Western pulley block system. It's differential pulley block or Western pulley block. It consists of the upper block and the lower block. So it has 2 diameters or 2 pulleys that are mounted on the upper block and 1 pulley on the lower block. And this attached to it, there is an endless rope. You must be able to sketch and label this. The velocity ratio of this machine is given as 2D. There are only two diameters that we focus on. It will be velocity ratio equal to 2D divided by the same diameter that is on the numerator minus the smaller diameter. So this is the formula to calculate a velocity ratio of a pulley system. D is the diameter of the larger pulley. So we only focus on the upper block. D is the diameter of the larger pulley, and the smallest D is the diameter of the small pulley. Mechanical advantage is load over effort, just like the formula of this side. Velocity ratio is different formula from this one. So when you are given a question, you will carefully read the statement and use the correct formula. If a question is based on Western pulley block or differential pulley block, this should be the velocity ratio. If a question is based on wheel and axle, this will be the velocity ratio. So both formulas will be given in exams. You can be asked to calculate the diameter of the smaller pulley, or you can be asked to calculate the diameter of the large pulley or velocity ratio. So you can calculate any of these variables. Now let me just show you how to sketch the differential wheel and axle first. So it is important to know how to wind the rope over this axle and the wheel. So the direction of the small axle and the wheel is the same. So the pulley, this is the rope, this is the rope, this is the rope. The weight always hangs on the axles. So the rope comes from the top, but on the large axle, it goes from the bottom to the bottom. Then it does this. And the direction of this one will be the same as the small axle. The rope comes from the top. So this is P or F for the effort. And this is the weight that can be in kilograms, it can be in grams, it can be in tons, always change to newtons. So mechanical advantage is equal to load, which is the load over the effort is the minimum force that you apply there, which is E. So these are both in Newton. Newton cancels out, it has no units. The velocity ratio is equal to twice the diameter divided by D1, which is this diameter, minus D2. So you must be able to fully label it from here to here. This is the diameter of the wheel, which is capital letter D. And from here to here, this is D1. And this is the smallest diameter, which is D2. So you must be able to label it, sketch and label, and do calculation on this type of machine. Let's look at that diagram. The direction, the rope here comes from the top, then here it goes on the bottom behind, then this way. And the direction of this one is also coming from the top, same as the wheel. Now let me show you how to sketch the differential pulley block or the Western pulley block system. This is the Western fully block system. I have two sketches so that it can face the left or it can face the right-hand side. So this is this type of machine. I'm going to sketch this one. So the rope, you attach it there. It goes on the lower pulley. It goes on the upper smaller pulley. Then the effort will be applied there. And label it as E for effort. Then we'll be pulling in that direction. You can also do it that way. It go over the larger pulley on the bottom pulley. Then and the effort is pulling in that direction. So you can sketch it face the left-hand side or it faces the right-hand side. Then you label this diameter. This is capital letter D. And the inner one is the small letter d. Mechanical advantage for both is load over effort. But the velocity ratio of this one is twice the bigger diameter divided by the same diameter that is on the numerator, capital letter diameter minus d. Efficiency doesn't change for all of the machines. It is MA divided by VR times 100%. So any lifting machine, the formula of efficiency does not change. Now let's look at a lever. A lever is a rigid bar that is resting on a pivot. So if this is the turning point of a lever, this side, this distance is shorter than this distance. So effort distance, E distance, is always larger than the load distance. So when effort is applied in this direction, the load will be moving in that direction. So this is a simple lifting machine. Mechanical advantage, same formula. Velocity ratio of this simple lifting machine is E distance divided by load distance. And mechanical advantage stays the same in the efficiency. So the only thing that changes is the velocity ratio, because when you look at pulley system, the distance taken by the rope is in revolution. But here, if you put here, the effort will take a distance which will be linear, which is different from the circumferential. Now let's look at the worked example of the activity. It is taken from the past question paper of April 2020. 5.4, a hoisting device is used to pull an engine with a mechanical efficiency of 75. So given MA is equal to 75, MA is given as 75%. And effort distance is 400 millimeter and the load distance is 300. So I'll write down the givens. Efficiency is 75%. E distance is equal to 4,000 millimeter. And the load distance is equal to 300 millimeter. You see the effort distance is larger than the load distance. Now let's look at the activities or at the solution of this activity. Let's first look at formulas that will be given in Excel. The formula of a velocity ratio, VV, or is DR. You know, it is DR or VR. It is SE. S is for distance and E is the effort. S is for distance, L is for the load. So this formula will be given. Also, mechanical advantage divided by dr. dr is velocity ratio, it's the same thing. So the formula of efficiency will be given is the same for all of the machine. dr, which is also VR, velocity ratio and displacement ratio, is the same thing. Is 2d divided by d1 minus d2. So this one is the differential wheel and axle. It's the one that has larger drum and two smaller drums. 2d divided by d minus d is equal to dr. We know it as dr as VR. So this is Weston pulley block or differential pulley block. The formula of its velocity ratio will also be given. So velocity ratio for a simple machine, velocity ratio for differential wheel and axle, velocity ratio for Weston pulley block will be given. So formulas will be given. Mechanical advantage will also be given is load over effort. All you need to remember is that this load must be in newtons. Now let's look at the activity. Calculate the velocity ratio of the device. This question does not specify that this is a Weston pulley or it's a wheel and axle. In fact, there are no diameters given, so this is a simple lifting machine. Calculate velocity ratio. So VR is load over an effort. So it's effort distance over a load distance. That is the velocity ratio. VR is given as SE. This is the formula that will be given in exam, divided by SL. Effort distance is 4,000. So you substitute the above given millimeters. So this is 4,000 divided by 300. You use your calculator to get what is 4,000 divided by 300. This is 13,333. 13,333. It has no units because millimeter will cancel out a millimeter. Also, if you convert this to meters, this will divide by 1,000. So it will be 4 divided by 0,3 if you change both to same units. So 4 divided by 0,3 will be 13,333. So for as long as they are both of the same units, you still get the same answer. Next question. Calculate the mechanical advantage of the device. Mechanical advantage is given by the formula load over effort. MA is load over effort. So number 2, MA is equal to L over E. And the load is the value of the load mechanical advantage of the device is pull the engine with mechanical advantage. Yes. So you are given efficient. The formula of mechanical advantage is load over effort, but you are given efficient. So let's have a look at this. The formula that has efficiency and mechanical advantage is this one. So you use the formula that has the given as well as the unknown. So efficiency, so this one is out because it has load is not given, effort is also not given. The formula that has the given is the efficiency is equal to MA over VR multiplied by 100%. So efficiency is given as 75% equal to MA is the unknown. Velocity ratio is 13,333 multiplied by 100. So this will be, we can cross multiply 75 times 13,333 equal to 100 mA, 100 times mA. It's on the numerator. Next step, we can divide both sides by 100. Both sides by 100. Can first get answer of this side and divide by 100. This cancels out. Mechanical advantage will be equal to this mechanical advantage will be equal to 75 times 13.333 divided by 100. The answer is 9,999, which is equivalent to 10. So mechanical advantage has no units. It has no units. This is how you calculate it. We're going to look at the second example, which will be specifically to the types of hoisting devices, differential pulley system, Western pulley block system. This one was a simple lifting machine. Thank you.